Hello guys, welcome you all again for this end-to-end session of AIML, where you guys gonna learn everything that you guys need for in order to become a successful data scientist. Guys, we are very happy, guys, because like it is like nearly 40 plus session we have done, and we are giving like a different way of approach of learning this AIML. We are giving a theoretical understanding of it, black box understanding of it, and then we are just moving on to the coding part like that we are giving. So guys, before coming to the session, as always, I'm just mentioning, guys, please make sure that you guys watch all your previous session videos so that you can have a better understanding of what we are talking. So today is the continuation of previous session, where in previous session we have just introduced you multiple linear regression. So today is a continuation of it. So please guys, please make sure that you watched all the session previously which are done by us, so that you can have a better understanding of what we are telling. So if you guys have any doubts, that's a major thing. Okay, if you guys have any doubts, just ping in the comment section. We will take up and we will just solve your doubts. Okay, just jump into today's session. So today's session, as I mentioned before, it is a continuation of multiple linear regression that we have done in the previous session. Please make sure that you watch this so that you can have a better understanding. Okay, so evaluating model performance, that is multiple linear regressions model performance, how we can do that. Evaluating model performance includes accessing the model's ability to accurately predict the dependent variable. Okay, then common metrics includes R squared, adjusted R squared, root mean square, and then mean absolute error. Okay, so these are the common things. Like whenever we are having a regression problem, right, we will be using these kind of things. Okay, in linear regression also we will be using these things, and for this multiple linear regression it is also a regression problem, right? We are using this kind of metrics. First is R squared. So it's a proportion of variance in the dependent variable explained by the independent variable. Okay, then adjusted R squared, uh, we will say that it is a something called as a penalized version. So it is a updated version of R squared that account for the number of independent variables in the model. Okay, then we are having root mean square error, that is MSE, that is the average difference between the predicted and actual values, taking into the account the squared errors. Okay, so in order to avoid the negative values. Then mean absolute error, that is MAE, that means the average absolute difference between the predicted and the actual value, providing a measure of average error. Okay, it will give the average error. Guys, just put it in a simple manner. These metrics are used to find the difference between the predicted and the actual value. Predicted value is the value which is predicted by our model. Actual value is the value which is present in the model, like data set itself. Okay, so we just need to predict what is the difference between the actual result and the model predicted result. That's it. Okay, for that we are having different metrics: R squared, adjusted R squared, MSC, and then MAE. That's it, guys. Okay, hope you guys have understand these things. Okay, because like this is a very important thing. Once your model is ready, right, you need to somehow evaluate it. How you can say your model is working fine, right? So you need to say your model is working fine based on these scores. Okay, hope you guys have understand. Yes sir, over to you.
Yes, so evaluating model performance. So these are the parameters which we'll be using. Okay, so R squared we use the portion of the variance in the dependent variable explained by the independent variables. So that is where we use so R square. Okay, and adjusted R square is where penalized version of R square. It is a penalized, like adjusted R, like they've been it is adjusted, penalized R square. Okay, you can say that. That accounts for the number of independent variables in the model. Okay, then we have RMSE, the average difference between predicted and actual value. That is what is called RMSE. Okay, taking into account the squared errors. Okay, so then we have MAE, the average absolute difference between predicted and actual value, providing a measure of average error. So these are the techniques we use to evaluate model, because when you use these models, it will give the performance, how much error is there. You can see it is like actual and predicted. You can see in RMSE. So it is the average difference between predicted and actual value, okay? Taking account into the squared errors. Same, they are just, these models are just predicting the errors and the variance. Like if you see adjusted R square, it predicts it will see the independent variable in the model. Okay, it will see like if you see that it is penalized version of R square accounts for number of independent variable in the model. So this is how these are different models which will help us to predict the accuracy and performance of the model. Okay, so we use these techniques to evaluate models. That is different. That is a fundamental concept for these models, and you have to go deep and understand at a meta level, which we have explained number of times. We have explained these models because you have to use them number of times. Whenever you are going for evaluating model, you have to use one of them. It depends how you're going to evaluate your model and what are the characteristics, what is the objective function. So you have to see that data characteristics and all those, what kind of model you're using, and it depends on that. You have to use these models to evaluate the performance of the model. Let's move to the other section.
Yeah, sure, sir. Yeah, moving on, we are having something called as, okay, great, interpreting regression coefficients. Okay, so whenever we are having a regression model, there will be some coefficients, right? This thing we have seen in the linear regression also. Let's see how to interpret this multiple linear regression. Okay, regression coefficients are crucial for understanding the relationship between the independent and the dependent variable. Yeah, that's true. The sign of coefficient indicates the direction of relationship, whether it is a positive or negative, while the magnitude indicates the strength of relationship. Okay, let's see what they are saying is it has positive, negative, and then magnitude. Okay, positive coefficient indicates a positive relationship between the independent variable and the dependent variable. So we will just consider an example. Okay, okay, so whenever you just okay, we will put it in this manner. Whenever we hours of a student study and then students mark. Okay, when the students study for 1 hour, the mark is 1. When the students study for 2 hours, the mark is 2. When the students study for 3 hours, the mark is 3. Like that, it will keep on increasing. That is called as positive correlation. That is, whenever the value of the independent variable increases, that is the hours the student study, the dependent variable, the student mark, is also increasing. That is called as a positive coefficient. Negative coefficient, so it indicates the negative relationship between the independent and dependent variable. Consider, okay, if the students doesn't study hour, okay, and their mark, if they doesn't study for 1 hour, then the mark is 10. If 2 hours, the mark is 9. 3 hours, the mark is 8. So can you able to understand, like, whenever the study hours like decreases, okay, then the mark is also like it will be decreasing. Okay, like consider we are having something called as the student study hour is 10 hour, but their mark is 1. 9 hour, their mark is something called as 8, and the 7 hour the mark is, so whenever the study hour increases, their mark is decrease. Okay, that means there is a negative coefficient. Consider we are having significant coefficients. Okay, it indicates a relationship between the independent and dependent variable in statistically significant. Okay, so what it mean significant coefficient, we need to have this dependent and independent variable in an optimal way. Okay, that's a major thing that I need to say. So this is how, guys, positive coefficient means whenever the value of x increases, the y also increases. Negative coefficient mean whenever the value of x increases, the y decreases. Okay. Significant coefficient means the relationship between this dependent and independent variable, that is x and y, should be statistically significant. That's it, guys. Okay. So, guys, like, please make sure that you guys understand these words, because like these are the technical terms. Whenever you are interviewed, right? As always, they're gonna ask you overfitting and underfitting. There will be no interview with it without this overfitting, underfitting, and then this positive coefficient and negative coefficient is also very important. Okay, try to understand it. If you guys have any doubt, just ping in the comments. We will take up and we will just answer you. Okay, yes, sir. Over to you.
Yes, so guys, interpreting regression coefficients. So the fundamental idea for this is that the regression coefficients are very crucial for understanding the relationship between independent and dependent variables. That is the fundamental idea, guys. Okay? So, the sign of the coefficient indicates the direction of relationship, positive or negative, increase or decrease. That's what it means, positive or negative. while magnitude indicates the strength of the relationship. So these are three things you have to understand. One is understanding relationship between independent and dependent variables. Second is the coefficient indicates the direction of relationship positive or negative, while magnitude indicates the strength of the relationship. These are very fundamental ideas for interpreting regression coefficient. Positive coefficient indicates positive relationship between independent and dependent variables. That's it. Not, no multiple ideas here. It's like it is positive relationship between dependent and independent. So guys, you will always see they're all, so I'll tell you in model independent and dependent variable there's a game going on. You'll see in each model these fundamental concepts. So positive coefficient means positive relationship between them, independent and dependent. That's it. No rocket science. Negative relationship between independent and dependent. That's it. No rocket science. Then significant coefficient, which is it indicates the relationship between the independent and dependent variable is statistically significant. So only the thing in significant coefficient you need to understand is relationship should be statistically significant. That's it. No need to remember all big lines and big things. Just understand the fundamental concept of particular concept and just absorb it. No need to remember big paragraphs and big books and stuff. Just understand the ideas and write in your own way. Apply them in your own way, in own language, own style, and people will respect you. Otherwise, if you just copy paste, then people will say you just copycat. So, understand in your own way, write in your own way, and then apply in your own way with consciousness. That is what is important. Even if you're making mistake, you do it with consciousness so that next time you will be aware what you have done. Without awareness and consciousness, if you make a mistake, then what will happen is you won't be, again, you will make that mistake, right? So that is why keep learning, keep improving. Let's move to the other section. Thanks.
Yeah, sure, sir. Yeah. So moving on, yeah, prediction and residual analysis, guys. This is also one of the key important thing that you guys need to know whenever there comes to a regression problem. Not like regression problem, any algorithm. Okay, let's see what it is. Okay, once a model is developed and evaluated, it can be used to make prediction for the data points. Residual analysis is a crucial to access the model accuracy and identify any pattern or outlier in the residuals. Okay, so this residual and prediction analysis is you have done with your model and your evaluated model. When you go for an unseen data, how well your model is performing, that is what this prediction and residuals analysis. Let's see what is one by one. Okay, predictions. The model can be used to predict the dependent variable for new data point based on the values of independent variable. Guys, just look into this word new data, that is unseen data. Okay, hope guys this is the same thing we are explaining like nearly like 3 to 4 sessions. Okay, now you guys are well versed with it. What is unseen data? The data which is not seen by the model, that it doesn't included in the training set, the test data, that is called as new data. So it is used to, the predictions is used to predict the dependent variable for a new data point based on the values of independent variable. Okay, great. Then residual analysis. Residuals are difference between the predicted and actual values, and they should be randomly distributed with no patterns. Okay, residuals are the differences between this predicted and actual value, that is the model predicted value and the actual value which is present in the data set, which will be randomly distributed. Guys, it's true, right? Not all the errors of the points will be same. Okay, then your model has memorized or you have done something different in your model. Okay, that should be different. That is called as residual analysis. What is the residuals of each and every point's error? Then model improvement. So these are the things that we can find it, right? Predictions used to predict whether our prediction is good, or model prediction is good with the actual result. Residual is used to find how different is the predicted and the actual result. The model improvement is done based on it, right? And residual analysis can help identify area where the model might be performing poorly, allowing for adjustments or improvements. Okay, and based on these two things, we can fine tune a model in order to make good prediction. Okay, hope this thing you guys need to know. Okay, guys, one thing, you are learning this theoretical concept, right? Actually, who and all just watch the previous session, they can understand there is only two lines of code. Okay, don't worry about it, but like try to understand this theoretical concept. Okay, if you guys are stuck anywhere, you guys have need more explanation, just put it in the comment. We are here and we will take it up. Okay, so yeah, that's what about this prediction and residual analysis. Yes, sir, over to you.
Yeah, so prediction and residual analysis. Again, here what we are doing is model will predict. That is what is the fundamental concept. Residual analysis. So once the model is deployed and evaluated, right? So it can be used to make predictions for the new data points. Residual analysis is crucial to assess the model's accuracy, identifies any patterns or outliers in the residual. So this is the main objective function for this concept. Okay, so predictions, model can use predict independent variable for the new data points based on the values of the independent variables. That's it. That is, it is, I told you, it's a game of dependent variable and independent variable. That's it. It's a game of, like, you have 1 rupee, you have seen one side, you have seen one written one, and the agricultural crop like wheat design is there, and the other side you have national emblem. So what is that? So same way you have here, one is the security, sovereignty, we have to protect that, and the other one is the economy. And these are two variables for a country, very crucial two variables, right? Same way for prediction of a model, so that you can remember it, independent and dependent variable, right? Even if you see, like, state government will be dependent for certain decisions, but it will be also independent in center. So you see that pattern in governance also, dependent and independent. So in prediction, this game will be played to predict. Okay, dependent variable for a new data based on the value of the independent variable. This is how the prediction will happen. You will understand more while we go into black box equation and math of it and then application. But here you have to understand objectively the concept. Okay, residual analysis. Residuals are the difference between predicted and actual. That's what is residual. The difference between predicted and actual. What is the difference? What is the difference between boy and a girl? That is a residual. What is the difference between wheat and rice? What is the difference? Is there difference or not? If there is difference, then that is residual. If difference is there, okay, difference between predicted and actual, and they should be randomly distributed with no patterns. That is what residual analysis is. Okay. So then model improvement. Residual analysis can help you to identify areas where model might be performing poorly, because once you know the difference, guys, with residual analysis, then and only you can go and improve the model, right? That is why residual comes in between. So allowing the adjustments or improvements. It's very simple, guys. So you can only do iterations, improvements when changes, when you understand what is the difference, where is the problem, okay, and prediction will help you to predict the independent variable for a new data, dependent variable for a new data points based on the value of independent variable. Okay, residual will help you to understand difference between two. Okay, and then and they should be randomly distributed. That is the condition with no patterns. Then and only you can go and make changes, improvements, iterations in the model based on you when you understand that. This is very simple, guys. Okay. So I hope you have understood it, absorb the information, digest the information, and apply. And keep learning deeply, have patience, and go and watch all the previous sessions 5 to 10 times so that you can have consciousness of AIML deeply. That's what I'll say. Let's move to the other section.
Yeah. So moving on. Yeah, guys. So finally, we are having the applications of multiple linear regression. Okay, multiple linear regression is versatile techniques with numerous application across various fields. It includes financial, healthcare, marketing, and education. I will say n number of fields. And we have here there is this much space to put. Okay, so that's the reason we are having only four. Okay, all the fields have an application of this multiple linear regression whenever you need to predict the continuous values. Okay, finance, it predicts the stock price, accessing credit risk, and something like analyzing the investment returns. So these are the applications when related to the finance domain. Healthcare domain, modeling patient outcomes, predicting disease risk, and optimizing treatment plans. Okay, these are the different applications that we are having for this healthcare domain. Where marketing, predicting consumer behavior, optimizing marketing campaigns, and analyzing sales trends. These are some of the applications which are related to this marketing domain. Education, predicting students' performance, identifying factors affecting the learning outcomes, and developing personalized learning plans, which are the application that we are having in education field. Okay, one thing, guys, whenever you are having multiple independent variable and your output is continuous, then you can use this multiple linear regression. Okay, so now you guys can understand, right? This is not limited to just this four field. There are n number of field which has the utility or use of this multiple linear regression. Hope you guys have understand this. Okay, so guys, I'm just saying not just this one algorithm, all the algorithm has the n number of fields application. The only thing you guys need to know where to apply, when to apply, what to apply, and how to apply. Okay, this thing is very very important. So yeah, yes sir, over to you.
Yeah. So application of multiple linear regression, guys. First, have focus and attention because paying attention to details is a crucial thing, guys. So when you're learning any concept, pay attention to details at a meta level learning. Okay, pay attention to details, and that is a quality of a scientist or a data scientist or AI researcher or any scientist. Scientists always pay attention to details, to the right what you say, right information, right abstraction. If you guys are from computer science, you will understand what is abstraction. Paying attention to right details. There are n number of information. Paying attention to right details, right information, right data set, right features, right concept, right ideas. Okay, so let's go. I'm just giving food for thought. Now let's go to the application of multiple linear regression. So multiple linear regression is a versatile technique with numerous applications across various fields, including finance, healthcare, marketing, education, and n number of wherever. I'll say, see, I'll give a definition to it. Wherever data is being generated, whatever data, and you can quantify, or you can um, transfer it to numerics, or you can convert, okay, transform it, okay. and that process can be automated, whatever industry. I'm giving a very uh, general AI definition that you can use AI, ML, data science everywhere if data is generated, and you can automate that industry and predict insights and give insights and improve the model or the business application or product service. AI can be applied. It's very simple because we need data. If we can make a model with that data and transform the business, that is the definition. So irrespective of what industry it is, if data is generated and we can automate, we can build model and we can improve the business. That is a definition which right now I have created with my experience and teaching you guys. So right now I just created, I got idea, I just connected dots. So finance, we can predict stock prices, assessing, we can access the credit risk, analyzing investment returns, healthcare modeling, we can model patients' outcome, predict diseases, risk, proactive healthcare we can bring. Huh? We can have hospitals with proactive hospitals, okay, with AI, ML, data science, optimizing treatment plans, marketing, proactive education. Like after 10 years, what is going to happen in education? Let's start working on that so that we have skilled people after 10 years. So, proactive finance, how we can remove poverty from the world. We can proactive economics, proactive. So that kind of, because that is what AI ML data scientists should do, proactiveness in each industry so that there is no reaction. We don't talk about problems, we talk about solutions and proactively solutions. That is what I think the essence of a data scientist or AI researcher or any scientist should be. We need to have news channels who should talk about solutions rather than what happened. They should talk about what will happen so that you have to do this, so that when that thing happens and then you have a solution in your hand, right? So that kind of world we need to have. So marketing, education, n number of industries where data can be generated and modulated and created models and automated, and we can optimize that process. We can apply AML data science anywhere, guys. Let's conclude this session. Go absorb the information, digest the information, and apply, and do all the assignments and keep learning deeply. Like until unless you don't learn for your curiosity and your simplifying or clarity, you can't have excellence, guys. Don't never ever ever learn and do research for money. Money is a byproduct that will come, that much you can't handle. But just learn for curiosity, ingenuity, clarity, and like a kid, no expectations, and keep learning lifelong. You will see you will have excellence. Once you have excellence, people will be after you. Okay? So keep learning deeply, have long-term objective function, keep absorbing, digesting, and applying the information, ideas, concepts, and let's see you in the other section. Thanks.
Yeah, guys, so hope you guys have enjoyed all the things that we are saying. Like yeah, this is all about this multiple linear regression. We will see you in the coding part. Okay, until the next session, bye guys, take care. If you guys have any doubt, just post in the comments. And one more thing, please subscribe to our channel, because like every day we're gonna post a new video, right? So please make sure that you guys have subscribed to our channel and click the bell icon so that you will not miss any of the notification. Okay, so yeah guys, keep learning, keep enjoying what you learn. Okay, so yeah, we are here to help you. So yeah, until next time and next session, like see you all guys, bye. We will all meet in the next session. Bye guys.